In the last video, we came across two transistors connected as shown on the screen. This configuration is called a superbeta transistor, and the most common type is a Darlington pair. It acts like a single transistor with a very high current gain, which is approximately beta of the first transistor times beta of the second transistor. We can see why this is if we look at the screen. Let's consider that the current going into the base of transistor 1 is 1 unit of current. This 1 unit of base current produces beta units of collector current and beta plus 1 units of emitter current. So why is this useful? We've already seen in the last video that we can use it to drive large loads. Large transistors, which can handle big collector currents, need large base currents because they often have low values of beta. So the first transistor is a smaller one and it drives a larger second transistor. Superbeta transistors like Darlington pairs are often useful in analog small signal amplification as well. This is because they have such a large value of beta that their base current demand is very small, and therefore they have a high input resistance, which can be very useful when biasing. Quite apart from this, they can also be used to simply give a very high current amplification. And similarly to their application in switching circuits, they can be used to drive large currents, for example in power amplifiers, in audio and radio frequency work. One issue which can be a problem with a Darlington pair in certain circumstances is that the base to emitter voltage of a pair is 1.4 volts rather than the usual 0.7. This is because there are two base to emitter junctions connected together. There are other designs of superbeta transistor which overcome this, the most popular of which is called the Sziklai pair, and this uses an NPN and a PNP transistor together to give a 0.7 base to emitter voltage drop.